Is Balz Schiemann reaction, and previously we have seen Sandmeier and Guterman reaction. So Balz Schiemann is actually similar to what we have seen in Sandmeier and Guterman. Just a difference is that we are using primary amine here. So there we are using like directly diazonium salt. Here we will be using aniline, which will be converted to diazonium salt, and there will be formation of a product. Let's continue with it, and this is the general reaction that I have written down to give you a simple understanding basics on what will be happening. So aniline works with HBF4, then there is HNO2, nitrous acid, formation of diazonium salt, that is the intermediate, and our final product, fluorobenzene, nitrogen gas, BF3. Let's continue with the mechanism now. So starting with the basic aniline that we have, NHH. So this is aniline. Goes forward with NHNO2, okay, and H plus. What will be formed will be somewhat like this. This H plus came from like this HBF4, so one of the hydrogens from this came here. So there is this intermediate that is formed. I'll show you. And then there is another nitrogen. The nitrogen came from here, so let's see this. N, O and OH. This is what is the nitrous acid looks like. There are two bonds here, two electrons of the oxygen, which will be reacting with the hydrogen given there. So there is OH formation, these, okay, and there is like two electrons remaining, octet. So to complete this, it will be attacking here on the nitrogen. So there is formation of this. So 4 bonds means positive charge, and there is like OH groups, 2 OH groups on this. So nitrogen will be completed, positive charge there. What will happen now? There are 2 hydroxyl groups on the nitrogen, which will be like unstable. So to stabilize itself, one hydroxyl group will be leaving with one of the hydrogens from this. So these two will be combined and leave. So minus H2O, this leaves, and the intermediate that is again formed is HN and HN double bond N, and there is one nitrogen hydroxyl group that is still connected to it. So this is what will be left after water is removed. The positive charge is still here as there are 4 bonds on the nitrogen. This will be coming down to again removing of water molecule. So N will be triple bond N. Okay, so this is what will be formed. This is benzene diazonium salt. Write it down. Benzene diazonium salt. So this is what is formed after the removal of OH and H, which is minus H2O. After this, coming here, there is BF4. As I told you, one of the hydrogens from this has gone here, so there is BF4, which is negatively charged. What will happen is, I'll show you. So there is BF3 and F. There are 2 electrons negatively charged. Okay, so this is the tetrafluoride that we have of boron. So what will happen is, boron tetrafluorate, the one fluorine that we have got, it will be working on the, I'll show you. AR is aryl group and N triple bond N. So this fluorine will be working on this particular bond, and this will be gone here. As there is positive charge, this goes here. There is a formation of free radical. So when the nitrogen goes away, there is formation of free radical N2. This free radical is then exploited with the fluorine atom that broke the bond between this, and then we can say that there is BF3 remaining. There is one fluorine coming here, and this is a fluorobenzene that we have left with, and this will be exothermic reaction, or some kind of light will be produced. So the heat symbol. So this is what is Balz Schiemann reaction. This is Balz Schiemann reaction, in which aniline is converted to fluorobenzene by conversion of the aniline to the diazonium salt that we got, and then it is converted to fluorobenzene by the formation of free radical, that is when the nitrogen is leaving and the BF4, one of the fluorine groups, attacks the free radical and fluorobenzene is formed. Thank you.